So what is it that makes this water in these bowls swirl around clockwise or anti-clockwise, just like this man wants them to be? Clockwise on the northern hemisphere and anti-clockwise on the southern hemisphere. I was suspicious the first time I heard about it. There are many things I started to think about. Could not be right. Is the equator exactly here? And then, for those of you who studied the Coriolis, what about the length scale? What about the size of the bowl? The amount of water? How fast is the water moving? It cannot be the Coriolis. But is it? It's really difficult. We were really skeptic and wanted to find out what is the water making swirl around. The first thing we thought about, is it the bowl? Okay, so we're gonna redo our own experiment to see. Here it's supposed to rotate clockwise, as the experiment says. As physics say, maybe something different. We're going to try with our own setup, brought all the way from Norway, completely clean bowl. We have a great crowd also watching. So I'm going to fill some water. So we're stabilizing the water. Yeah. And straight down. Ooh.
It's not working.
And it's supposed to rotate.
Maybe we try another place.
Yes. You think
not
it's the place is not good.
Yeah.
So even though we're in the north of the equator, it should work. So we're on the northern hemisphere. We're going to stabilize the water first. Make sure it doesn't move. Very good. Do you want to put in the flour afterwards? Yes?
Yes.
You put it in the middle, right?
Yeah.
Yeah? Okay. Taking this out. And then I'm going to pull the plug.
That one first.
Okay.
Take out now.
Now you put on the flour.
Supposed to be like
And it is not rotating.
this. Let's try again.
We try again. That's with all good physics experiments. You have to do them many times. Right?
Yes.
Okay. You think it will work now?
You think so?
Yes?
Let's try.
I think it will work. Let's try. So we're going to fill some more water. You can hold that for a second. Right. Take them. Stabilizing the water again. Okay. And then you put in the flour.
Yes. It's not working again.
It's not working. There it is rotating. And it is working. Good work.
Thank you.
High five. We managed it to work. Very good. Isn't that interesting? Isn't that fun? So now we saw that our experiment worked on the northern hemisphere. First it did not rotate at all, but then at the second attempt it actually rotated clockwise, as we saw in the previous experiment. So now we're going to try to do another experiment. We're now on the southern hemisphere to see if it will rotate anti-clockwise. Okay. You have the flour?
Yes.
It's good. Alright, so we're now going to stabilize the water on the southern hemisphere, redoing the experiment, a complete clean funnel. Alright, taking it out. You put in the flour?
Yes.
Okay. Oh, it was rotating clockwise. That's strange. We try once more.
Yes.
Okay, so we're now going to do another experiment on the southern hemisphere. You are flour responsible?
Yes.
Good, good. I'm pulling the plug. Yeah. And it is rotating a little. Oh, not rotating anti-clockwise. That's weird. We're doing another experiment on the southern hemisphere. You ready with the flour?
Yes.
Yes. Okay. Yeah. Put it in. And it's not rotating. Alright. So the Coriolis experiment remains a mystery. How can it work? I've conducted several experiments here on the equator, north of the equator and south of the equator, with different bowls, different funnels. I've tried taping the inside of the bowl to see if I could induce a spin, which did not work. All studies were conclusive. Sometimes I had some spin, sometimes I had none, both north of the equator, on the equator and south of the equator. So what makes this experiment work when I do not do it? I don't know. However, I hope you enjoyed watching and get a little bit intrigued. Greetings from the equator.